Hey folks, well, now that we've looked at functions and scoping and a couple of our different choices in terms of pass by reference or pass by value, I wanted to take a bit of a look at the use of functions in the overall design of our programs so that we can come up with a, if you like, a clean design that makes it easy to understand our code and easy to maintain it and modify it later on. So there's a couple of different design concepts that I want to introduce now, top-down design being one of them and modularity being another. So our functions allow us to take, in essence, a code segment, take that away, give it a name, and when we want to run that code segment, we just simply call the function. This allows us to say, well, let's take a chunk of code related to some particular task. The chunk of code related to getting a password, or to getting a value from the user, or to performing some computation. We take this chunk of code as kind of a logical task, give it a name, right? Put it in a function, and when we want to perform that task, we simply call the function. Now, when I'm writing other parts of my program, I don't have to worry about the gory details of, what does the code actually look like to make that task happen? And it might be pretty ugly, pretty ugly little chunk of code off inside that function somewhere. All I need to know now is how to call the function, right? What parameters to pass, what the function name is, and what kind of a return value it gives me. So there's a whole bunch of gory details about the function that I no longer need to worry about. So this kind of abstracts away the gory details of the functions. All I need to know is, what task does that function accomplish for me, and how do I call it? So this really simplifies how much detail we need to keep in our brain at any given point of our programming. It also works the other way around. When I'm writing the function itself, I'm just focused on how to accomplish that task. I don't care who needs me to accomplish that task. I don't care, where they're going to call me from, what they're doing before they call me, what they're doing after they call me. All I know is they're going to give me these parameters. I have to give them back this kind of a value. I know the task that I have to accomplish, and that's all I care about. So when I'm writing the function, I don't care about any of the details of the rest of the program. Right? As long as they call me correctly, I'm going to give them back what they want. I'm going to do what they want and give them back what they want. And when I'm writing the rest of the program, I don't need to care about how the function accomplishes it. I just trust that it's going to work, and I call it appropriately. So this simplifies the amount of information that we need in our heads at any given point in the program. And this is where modularity is eventually going to come in. Right? Big impact on the readability of our code, big impact on our ability to perform maintenance. Right? When I'm reading one function that calls another. Say I'm reading my main routine, and it calls 3 or 4 key functions to do whatever the program happens to be. Those functions are probably named something close to the tasks they're accomplishing. Welcome the user, get the data, do the calculation, display the data. Right? Something that's relatively intuitive. And so when I'm reading my main routine, I'm seeing these nice, clear, intuitive, high-level steps. And my main routine is easy to understand and easy to follow through. I might be declaring some variables to store return values in and to pass as parameters, and making sure I've got that sequence of information exchange correct. But I don't care about any of the gory details in all of those different tasks. So reading my main routine is nice and simple. And again, when I go off and read one of the different functions, say I'm reading the one that's going to get the data from the user, I don't care about the gory details of how the main routine works or what it's going to do with this information. I don't care about the gory details of any of the other functions. I'm just looking at my task at hand. So this makes it much easier to write and to read any individual chunk of the program. It also makes it much easier for us to modify the program later on. Suppose that I want to go through and, I think I've chopped off the bottom of this a little bit. Suppose that I want to change the prompts that I'm using to get the user input, or I want to add some extra error checking into the user input. That means I wind up going in and rewriting the display or the get input routine, but none of the rest of the program changes at all. So I can kind of think of this one chunk of the program as being an isolated piece unto itself. I can modify it, I can rewrite it, I can do whatever I like to it, as long as it still meets its overall objective of getting the information from the user and giving it back. And so we've got this kind of plug and play mentality where we can say, well, I can take any one of these functions and rewrite the insides completely. And as long as it still accomplishes its objective in the big picture, the rest of the program doesn't care. The rest of the program doesn't need to know about it. And this means I can also divvy up the tasks between different programmers. Here, you go write up the first function, you go write the second function. And as long as we've agreed on what the objective is for each function, and we've agreed on the name, parameter list, and return type of each function, then it should all work when we all put our pieces back together and here's this function, somebody else says here's that function. When we put it together, it should work as long as we've all agreed on what the purpose of each function is and what that profile for each function is, what that prototype for each function is. So this has a big impact on our ability to kind of decompose and write code, maintain code, alter code, understand code. So this kind of modularity idea is a big part of our target in our design of programs. So again, our functions are a first step towards that idea of a modular design, right? Creating a program of a bunch of interlocking parts where the internal details of any part of any function are hidden from all the others, right? They don't need to know how any function accomplishes its task as long as it gets the job done. So it does mean that we need to agree up front on what task each function is supposed to accomplish, and we come up with the name, parameter list, and return value for each of the different functions. Right? As long as we've got that, then each of us can go off and write our own parts, call each other's functions appropriately because we're trusting that the other developer is going to write their part correctly. We can take any individual function apart and rewrite it and change it as long as it still ultimately accomplishes its objective and doesn't mess up the profile. And so we can now modify, design, implement all the different parts independently. And with each of them, we're only focused on the details for that one part while we're working on that one part. So with top-down design, we're going to take this idea and sort of apply it in a layered sense. So if I've got some big complex problem that's ultimately going to be divided into, maybe dozens and dozens of functions, what I'm going to do is take it one layer at a time. When I'm thinking about the top level of the program, I'm going to think of it in terms of a few major tasks. Get the data, process the data, display the data kind of thing. And when I'm writing my main routine, I'm just going to focus on those few tasks. So what if I'm going to regard those say 3 tasks as one function each, what parameters do I have to pass to the first one? What's it going to give back? And so what variables do I need to store that? What parameters does the second one expect and what return value is it going to give? And so again, what variables do I need to exchange the information? But I'm just setting up the variables and calling the 3 functions. Now at the next layer down, those 3 tasks might each still be pretty complex. Those 3 functions might still have an awful lot to do. So I look at those, let's say I look at the first one, my first big task A. And I say, okay, well, this is still pretty complicated. So I'm going to take my big task A and the function that represents it and have it call 3 or 4 simpler tasks, right? The 3 or 4, if you like, subtasks for that particular step. And so I'm going to write a function for each of those. And so my function for task A is just going to call the, let's say the function for subtask X and the function for subtask Y and the function for subtask Z. And we just keep breaking it down like this. If a problem, if the task at hand is still pretty big, then we say, okay, well, let's divide it into 2 or 3 or 4 kind of key substeps and write a function for each of them. And then we'll go off to those functions and say, well, if that one's still pretty complex, I'll break it down further. And you just keep going down the chain, breaking things into smaller and smaller tasks, smaller, represented by smaller and smaller functions, until eventually we get to a point where we look at the description of a task and say, oh, well, that's easy. You know, I can write a 10-line function to do that easy enough. And so we'll just write that one there and then. And so you wind up with this hierarchy of breaking our problem up into smaller and smaller pieces, each one represented by a function, and eventually we come up with a nice, clear design for our overall program. So this is the notion of top-down design, where we just keep breaking each layer up into smaller and smaller pieces. So again, pretty much if we've got our big picture, so this one's going to be represented by our main routine, for instance, and then we say, well, our big picture is we've got 3 big tasks. So I take those 3 big tasks and write a function for each of them. And again, if they're complicated, then I break it up further and say, okay, well, subtask A is pretty complicated. I'll break it up into 3 smaller tasks and write a function for each of those. Right? So you just get this kind of hierarchical breakdown until you get to simple pieces down at the bottom someplace that you can just simply write. And again, subtask B might need to be broken down into 2 or 3 or 4 or 5 steps. Subtask C might need to be broken up down into 2 or 3 or 4. Or maybe it's a simple one already. Maybe subtask C is easy enough to just write right there. But this is the kind of top-down idea, the hierarchical idea, where we just keep decomposing until we arrive at pieces that are simple enough to just do. So this is something that we're going to focus on as we design larger programs throughout the rest of the course. All right, that might be a good point to leave our quickie intro to design.